Welcome to another Maplecast. In this episode, we're going to be taking a look at the dsolve command in particular, talk about several of the applications of the command and ways to learn more information about the differential equations you're solving if Maple doesn't actually work, which sometimes happens. So I'm going to start by suggesting that when you are using differential equations in the course, you go ahead and define the ODE. You can call it whatever you like, but go ahead and define it. That way when you use dsolve, you can just say dsolve the ODE and then solve it with respect to y of t. So I'm going to store ODE, and if I take off the colons, we can see what it is I stored. I stored this differential equation. Now, if you've been paying attention in class, you should know that this differential equation is what we call the exponential ODE in class, or the exponential model. And it really simply is just solved by taking e to the integral of this right-hand side, 2t squared term. And you can see in Maple, if we want to dsolve this equation, we simply enter the differential equation as I have it written here, and then tell it to solve for y of t, the dependent variable in this case, being y as a function of t. So if I hit enter and do dsolve, you can see that I get a explicit solution equal to this is how Maple does its constants. So this is constant number 1. You can solve for the constant if you like by right-clicking and telling it what you want to solve for. You can isolate expressions for any of the variables in the problem, obtain solutions for different things. There's lots of contextual things that you can do by right-clicking on the outputs. But notice 2/3 t cubed is just simply the antiderivative of 2t squared. So this fits what we've learned in class about this exponential model. This should be the solution. And the idea is I've updated this by defining p of t as 2t squared. That's why when you looked here, it says p of t times y of t, but down here I defined p of t to be the function 2t squared. That's why it inserted 2t squared right here. Okay, if I didn't want p of t to be defined that way, I could use what's called the restart command to basically clear all of the definitions. So I had stored p of t to the function 2t squared. I had stored ODE to this differential equation. By doing restart, it basically wipes all that clean. So what you can see now is if I go in and hit this now, it doesn't know what p of t is any longer, and it just gives me the differential equation. If I solve the ODE, you see that solution formula we talked about in class. It's just e to the integral p of t dt. And now if I define p of t to be the function 2t squared and do the dsolve again, then I will get the general solution that we saw earlier. I do not have to always use the command diff y of t comma t. I can use the prime notation. And in fact, that works, I believe, up until you get to a fourth derivative. If you ever do any fourth order differential equations, which there's a couple of models here and there where that might occur, you're going to want to rely on the diff command, and I'll talk more about that in a later video. But here's just a simple differential equation that we want to dsolve. And you can see here it gives me a general solution. The reason I'm doing that is because without an initial condition, that's all dsolve can give you as a general solution. It cannot solve for the constant. So how do you include an initial condition? Well, you take the same input that you had for dsolve, and you wrap the ODE in curly braces along with the initial condition that you want to satisfy. In this case, y of 0 equal 1. If you then hit enter, the output will be what we call a particular solution in class, where I have solved for the constant, and judging from this, it looks like the constant would be -1 here. So y of 0 equal 1 forces C1 to be -1. Okay, if I want to change things up a little bit, I can get something here that gives me absolutely no answer. And that can happen. Sometimes you can enter a differential equation to solve, like this one, and basically Maple just punts. It doesn't know what to do. So my suggestion in those cases is to enter the command info level dsolve equal 3. Now what this command will do is it will show you behind the scenes what Maple is trying to do to solve the question, and it will tell you what techniques it's tried, what kind of equation it is, and it will also show you when Maple just gives up. That way you know, is it something you did wrong or is it something where Maple just doesn't know? So after I've hit enter to enter the info level for dsolve, if I hit enter again, it's going to show me all the different things it tried to do to solve this equation before it just finally gave up. So these are all the different solution commands or algorithms it has at its disposal for solving equations of this type. And it ran out of things to try, and it just basically punted at that point. It said, I don't know how to do this, and that can happen a lot with differential equations. Seemingly easy differential equations can be very, very difficult to solve, at least generally. We can always solve them numerically, and we'll talk more about that later. Okay, so let's go ahead and keep the info level where it is. I'm going to solve another differential equation here. You can see this differential equation turned out to be separable. So you could probably do this problem by hand, although the integral that you're going to end up with involves a hyperbolic tangent function, so it's probably good that we didn't do it by hand. But here is the general solution for this differential equation. All right, change things up a little bit. This one tried a whole bunch of things to try to solve, and none of them are really working. So sometimes it'll try more things before it punts than other times, and sometimes it'll work for a long time before it can come up with something. But here, nothing worked. So I'm going to actually suppress all that output. And try on this next one. Okay, the next equation I have here for dsolve is actually a Bernoulli equation. And the Bernoulli equation here successfully spits out all the different possible solutions. Now we talked about this in class, but sometimes it's better to be looking at an explicit solution than an implicit one. So I'm going to return the info level to 0. That way I don't have to keep seeing all the blue type when it tries to solve the equations. And I'm going to resolve this one we just got through solving, except I'm going to use a special addendum or a special option, if you will, for the dsolve command. And that is, I want to tell dsolve I'm looking for an implicit solution. So this is the same differential equation here as above, solved implicitly. It uses a Bernoulli technique, which is a technique that if you're working on the homework, you'll run into Bernoulli equations. But it uses the Bernoulli technique to solve it. It just goes a step further and solves it explicitly here, whereas here is the implicit solution. Now the benefit of the implicit solution is much easier if you have an initial condition. So for instance, if I was to try an initial condition here, which remember requires me to wrap this inside curly braces, but suppose I want to try initial condition of y at 1 equals 0. So that initial condition led to solving for C1, and that made C1 0. So you can clearly see how the constant has changed when you do initial condition calculations. And so I think a lot of times the implicit solution is the better way to go for some of these more daunting looking outputs that dsolve might give, when it gives you, you can see here 1, 2, 3 total answers. And anytime you see this capital I, you know that that answer is complex. So it's giving me some very complicated answers. There's only one real solution, and that's the solution right here. And then there are a complex conjugate pair of solutions. We'll talk later in the semester about complex solutions, but for now, we're really going to want to focus more on implicit solutions early on in the course. And so I wanted you to see the implicit command associated with dsolve. I think this is a pretty thorough introduction to dsolve. There's not a whole lot other than this that we're going to do this semester. These are all first order examples. Later in the semester, we'll have second order examples of dsolve, but the command itself doesn't really change. You simply enter dsolve followed by the differential equation you want to solve, followed by the variable you want to solve for, which is always the dependent variable. All right, I hope that helped. Thank you for watching.